In this video, I'm going to be talking about the term or what is meant by chemistry. We'll be talking about different theories and laws, and then we'll be also talking about the scientific method. So after this video, the goal is that you're able to define, describe, and what is meant by chemistry, also distinguishing between theories and laws, and then also be able to restate the process and the purpose of the scientific method. So starting out, the question may be, well, what is chemistry and what am I actually going to be doing this semester as we go through these different topics? So these are three definitions that I found that I think altogether describe what chemistry is. So chemistry is the branch of science that deals with the identification of the substances of which matter is composed. It's the investigation of substances' properties and the way in which they interact, combine, and change. And it is also the use of processes to form new substances or to optimize the processes we already have. In all of them, I've highlighted the key words that we're focusing on here. Notice that everything says substance, substance, substance. So chemistry is essentially the study of substances. What do they do? How do they interact? How do we make them? How can we make them better? The formal definition or the formal way to call something a substance is actually matter. So we are going to be studying matter throughout this semester. So it's a good idea if we know what matter is and have a firm understanding, since this is what we're going to be studying all term. So in our discussion of matter, what we're going to be looking at is, first, in the first part of this semester, we're going to be building our foundations. So what are we going to be looking at to build those foundations? We need to know what the scientific method is. We also need to know how to do different types of problem solving and take measurements. Since chemistry is a science, it involves measurement and study. We have to know how to properly analyze those things. We also have to know how energy is related in reactions and in chemistry. Since it's related to just about everything we do, we need to know what that is. We also are going to be studying atoms and elements. Those are our fundamental building blocks, and looking at how to use the periodic table. The second part of this term, we're going to be actually putting those atoms and elements together to create compounds and study their reactions. So we'll be looking at molecules and compounds, chemical reactions, and then everyone's favorite is actually doing the calculations with chemical reactions. If you've heard of stoichiometry, if that gives you anxiety, that's when we'll start looking at that. And hopefully, if it does give you anxiety, it goes down after you study through this semester. The third part of this term, we'll be looking at structures and interactions of molecules. So what are their structures, how do they bond, and how do they interact with other things going on nearby. And then lastly, in the fourth part of this term, we'll be looking at specific branches and topics in chemistry. So organic chemistry, if you've ever watched a movie of chemists or they had chemistry going on, you see all that crazy glassware going on in the background. Typically that's organic. We'll also be looking at solutions or different types of solutions in chemistry, acids and bases, gases, and then nuclear chemistry. So all of these different unique topics, once we build our foundation, we can then talk about these different specific branches and topics that we'll see throughout Chem. So in order to kind of study all of this, there has to be some research that has been developed or some type of way to come to these conclusions that we're going to study. So how do we get those behaviors of gases? How do we know what those properties are? How do we know that the periodic table is designed a certain way? And anytime we're reading through anything or anytime we're going through anything and you're wondering where this stuff comes from, the process scientists have used to design these things is called the scientific method. And many of you have probably heard of this, but this is just the process used by scientists in order to investigate questions based on their observations and form some type of conclusion from them. So the scientific method has this basic process. First, you make some type of observation, typically. Based on that observation, you usually ask a question like, why does that happen? Or the sky is blue. Why is the sky blue? You form a hypothesis. I think the sky is blue for this reason. Then you do some type of experiments to test your hypothesis. You analyze those results. So did it confirm my hypothesis? Did it not support my hypothesis? By drawing my conclusions. And then I can either choose to communicate my results or go back and adjust. Notice how this picture has things connected in all kinds of different ways. Essentially, the point here is that this is not necessarily a step-by-step process. I have to make an observation, and then I have to ask a question, and then I have to form a hypothesis. All of these things are interchangeable, interflowing, and it's a constant process in order to kind of get to your desired results of being able to communicate them in either a journal or a published paper. So yes, it is logic and systematic in that you have to do tests and have some type of analysis of your results, but it's not necessarily rigid. The main focus here is using those experiments and observations in order to figure out what's going on, in order to get some type of scientific understanding. Even if your hypothesis is not supported by your conclusions, that still is giving you some information. And lastly, if you do enough experiments or follow this process as well as possible, it can actually lead to the development or thought of laws or theories. So first off, we're going to see a lot of these throughout the semester. Different scientific laws and different scientific theories that have been described in our textbook, or we're going to be talking about different types of information based on these. So it'll be really important to know what the purpose of each is. So the purpose of a scientific law is just to describe what is happening. This usually summarizes past observations and predicts future ones. So what are you consistently seeing, and what can you expect to happen over and over again? For example, an observation would be the sky is blue. Or an observation would be that the color of this apple is red. That's just explaining what is going on. It's not necessarily telling you why it's going on, what is the reason behind it. It's just telling you about a consistent observation, and it will allow us to predict what is going to happen. These scientific laws usually fit lots and lots of data. So there are lots of support, lots of different information that support that law. That means they're highly supported by experiments. Although they can be changed, usually something doesn't become a law until it has been observed so many times, so consistently, that it just becomes a natural phenomenon or a law that happens. My example here are two carts. I tried to pick one that I feel like most people probably have heard of at some point in their life, and that's the second law of motion from Newton, which just says that force equals mass times acceleration. So the larger the mass, if I compare these two masses and I apply the same force on pulling on those masses, we all know that a smaller mass can be pulled at a higher acceleration than something with a larger mass. So how fast can that accelerate depends on the mass. Now, this is considered an example of a law because this is consistent observation. This is happening all the time, and it's just predicting that if I get an even heavier mass or lighter mass, the acceleration will be proportional to what's going on. So it's predicting future observations and summarizes consistent observations that are happening over and over again. Then the purpose of the scientific theory then is to expand on that law and try to give explanation and meaning to that law. So why is that actually happening? Why is the cart moving at a higher acceleration when the mass is smaller? What is going on? So the scientific theory tries to provide that explanation as to why something is observed. Why am I seeing this? Why is this consistently happening? A lot of times this also has lots of data to support it, to back up why I'm explaining this is happening. A lot of times your scientific theories do tend to be challenged and changed because the understanding of why is a little more difficult to come by than just seeing what's going on. You're trying to explain what's going on. Even if they do end up not being true or not necessarily supporting your original thinking, they do help us discover new things. So they do usually require lots of data in order to support, but even still, that explanation as to why is a little bit harder to come by than just seeing a consistent observation. So the example I have down here is the original thinking of our solar system. So the observation people made is that the sun sets and the moon, sun rises, sunset, moon rises, moon sets. So they said that there's some type of rotation going on. They said that the Earth is the center of the universe, and then the different things are rotating in orbit around the Earth. That was our original theory behind the arrangement of the solar system. This diagram here is our current understanding of the solar system, where the sun is the center of our universe, and then our planets and different things are orbiting, different stars and such things are orbiting around the sun instead of the Earth being the center. So yes, this original theory helped us understand and get us to our current theory that we have now. So let's just check in to make sure we understand the difference between a theory and a law. So the continents drift at a rate of 1 to 12 inches per year. Does this best represent a theory or a law? This best represents a law because it is explaining what is consistently happening, not necessarily why it's happening, but that it is happening and being observed consistently. The continental drift is caused by convection currents. This best is an example of a theory. The reason is because it tries to give a reason behind what is causing the continental drift. So this is a theory giving you that because. Evolution occurs because of natural selection. Is this best representing a theory or a law? This best represents a theory because it is trying to explain what is causing evolution or why is evolution happening. It's happening because of natural selection. Species change over time. Is this best representing a law or a theory? This best represents a law because it is describing a phenomenon that is consistently happening and observed. It doesn't tell us why it's happening, but it's telling us that it is happening and it's a consistent observation. Lastly, matter cannot be created nor destroyed. It can only change form. Is this best representing a law or a theory? This best represents a law because it is telling us what is happening consistently every time you see matter. It cannot be created nor destroyed. It can only change form. This specifically is called the law of conservation of matter or law of conservation of mass. So stay tuned for the Chapter 3 video about matter to learn a little bit more about this law and exactly what matter is. This concludes our video on Chapter 1, where we learned about the scientific method, theories and laws, and the basics of what chemistry is and what we will be covering through this semester.